Good evening, everybody. Welcome to Unacademy. Welcome to our class of networks. Today we are going to discuss a very exciting topics, guys. So just stay tuned. We'll be discussing in the best possible way. That is resonance. Even you missed my earlier classes, it is fine. You can continue from today. You can attend the resonance class. You will be able to understand, guys. So we'll be starting the resonance. Let me introduce myself. I am Sankar. I did my MTech from IIT Kharagpur. I have around 10 years of teaching experience in GATE and ESE throughout the country. I am expertise with the subjects of digital circuits and network analysis. I am here to train you in the best possible way. I am very known to teach to the students who are very weak or who are having zero knowledge in the subject to the next level required for your exam. So let's go, guys. So if you are planning for an Academy Plus subscription, sir, why an Academy Plus subscription, sir? What is the difference, sir? In YouTube, we are daily giving you the free lectures in the best possible way. Me and total our team is helping you guys. Other than this, in YouTube, you have some certain disadvantages because it is not a dedicated learning app. But if you go for an Academy Plus subscription, it is a dedicated learning app which have more number of features, more interactive. You can feel like attending the daily face-to-face class. Okay, more interactive. You can chat immediately, instantaneously with the educators, and you will be having the classes in two languages, in your own language, Hindi, and also in English. And also you have regular doubt clearing sessions, and you will be having regular exams, subject wise, weekly exams, monthly exam. Unlimited practice is free with your subscription, and test series is free. We have multiple batches, guys, but for all of them you need only one subscription. If you take subscription, you can attend any batch in Unacademy, guys. So you can attend the live classes, or if you miss it, you can watch them in the recorded without any limitation, unlimited number of times. So if you are planning for subscription, this is the best thing you can get. If you want to go for, if you want to prepare for GATE exam, if you don't have any financial constraints, don't delay it, guys, because your fee is going to hike from October 20th. So before that, you plan your subscription, mainly second, third year, guys. So don't delay it. Now itself you take the 2 year subscription. So final year and pass outs according to your requirement. You can choose any plan according to your comfort or your level of the preparation, but don't delay it. If you have no financial issues, this is the best thing you can get. Whatever you pay, later you feel it is 10 times worth than what you are paying, right? So it is for your bright future only. So if you select pick a goal, GATE and ESC, go for GATE subscription. This is the process. Go to the Unacademy app, select the goal, select GATE and ESC, select GATE subscription. Then you will be getting the price plans. Then you can select either 24 months or 12 months, which are more economical. If it is suitable, you can select 1, 3, 6 also. There also you can watch all lectures, no restrictions. But it will be better and more economical if you select 12 months and 24 months. After that, go for applying the code. This step is very important, guys. Please don't miss it. Don't take, you can apply any code of your wish. If you like my teaching, if you want to join an academy, this code is compulsory, right? So guys, this code is not for my classes, it is for whole GATE and ESC subscription. You will be getting 10% extra discount on your total GATE and ESC subscription, any course in Unacademy. In fact, whatever may be the months or duration, it doesn't matter. On all courses, not only GATE, SSC, JEE, everything, you get 10% extra discount, and you will be getting for this price, guys. So let's move. So please remember this code. What is the code? Shankar 10. This should be registered in your mind. If you take or your friends want to take, refer this code only, guys. Right? So let's move further. So you can go for some EMI options. There is a part payment also. So on or before 19th, if you are not able to arrange full money, you can make a part payment, and remaining you can complete in 1 week or 10 days. Even you don't have credit card, no problem. This option is also there, guys. Okay. So you can make the part payments if you have some issue in the making it in once only, or you can go for EMI options of credit card, HDFC, or debit or Bajaj EMI. This is the code, guys. I'm again reminding. Right. So please note this date from October 20th. Your fee is going to hike. Before that, you take the low cost advantage and join an academy, guys. So this is our Hindi and English schedule which is free for you in your YouTube channel, guys. Please share with the maximum number of students so that whatever we are working for, that goal will be achieved. More and more students will be able to learn. That will give us more and more happiness, guys. So every Saturday, Sunday we are meeting for the digital circuit crash course. You can attend that also. Right. So yes, we are here to talk today on new topic called resonance. So let's start, guys. Are you ready? Yes, Nibai, it is for all branches, right? Yes, Bhaskar, I will discuss that at the end of the class. Iconic is also there, plus is also there. We will talk about it at the last. So if you have any queries, you can also contact me. 1 minute, guys, we will start. On Unacademy app, just go to my profile. You can message me there. Okay, you can just message me there in our Unacademy app. See my profile, go there, you can message me for any queries, guys. Let's continue, guys. Okay, so good evening all. Let's start the exciting topic that is called as resonance. From childhood, from your plus 2 also, you might have studied the resonance topic, yes or no, guys? So now we are here to discuss a little more other than what you know it earlier. Okay, so that is what we call resonance. So everywhere in your practical life, day to day life, you can see this resonance phenomenon. So why can't we analyze the same thing on our electrical circuits also? We will be discussing that in the electrical circuits also. So let's have some basic regular examples or background behind your resonance. Generally the resonance will do one thing. It will give you the best possible response at one particular frequency. That is, it will give you the frequency responses that you will get the maximum response at a particular frequency. That is what we call resonating frequency. Let's see what is the meaning of resonance and all those things, guys. Yes, Vijay, I am teaching in both the languages, Hindi and English also, right? So in your day to day life, guys, in your day to day life, you can see this kind of examples of resonance. You might be knowing it. When this particular string is vibrated, okay, there will be some hollow place in the bottom in the air. It will resonate and produce you the sound, guys. You know it. Every body will be having, every object will have its own natural frequency. If you vibrate with its own natural frequency, if you match it, you get a more maximum response. Similarly, our RLC circuits will also have some natural frequency. We are going to discuss that further. Okay, you might be knowing this, some general day-to-day life examples I am giving you. So I hope you know this example very well. From your schooling itself, you have studied. When soldiers are marching on the bridge, they should be, if all of them march with the, what if the frequency is matched with the frequency of the components of the bridges, then there is a chance of like this, it can collapse. Okay, so when we design it also, when you fix the bridge or when you design the bridge also, you take care of the different frequencies you are having, the natural frequency of the components you are connecting. And this is a classical example, you might be knowing it. So breaking the glass. So if the singer sings a song with which matches to the frequency of the glass, then high energy transfer can takes place. These are the basic examples, you might be knowing it, guys. So let's explore electrical engineering examples. Okay, or you see in music system, when when you are playing the music system high beat, then you can see your walls, your doors, everything will vibrate. This is also because of resonance only. This is also because of resonance only. Yes, right. Now we are going to our case. So this is an example of our electrical circuit, your radio. In radio, you will be tuning to a particular frequency. Then you get, because in your space all channel signals are available, but you are able to listen to one particular channel only. When you choose to some 99.3 megahertz frequency, you will be receiving only that particular frequency. Remaining frequencies you will not be able to receive. This is because of the phenomenon called resonance. In the resonant circuit, the response will be maximum at the resonant and it will be minimum at the other frequencies. So because of this phenomenon in your television remote or your radio channel or whenever you tuning a particular frequency, you get response which is maximum for that particular frequency, which is low for the remaining. So you will not be able to receive the remaining channels, you will be able to receive your required channel only. Okay, so now listen here. Right. So now you can see your microwave heating. There are so many applications of this resonant microwave heating. Everywhere we will be using this what we call resonance. Resonance, the phenomenon. We are exploiting this resonance in your audio systems. Not only in audio system. When I speak, my this oral cavity will be vibrating with some resonant frequencies, which will produce you the sound. When you listen also, your ear will be having the filters which are having a different resonant frequencies. So like that in your everyday day-to-day life you can see the phenomenon of resonance. Now we are going to discuss the resonance in electric circuits. Are you ready guys? Show me your energy. Are you ready guys? Are you ready guys? Please comment. I'm waiting for your comments. I'm very excited to give you the best possible knowledge. Before going to the resonance topic originally, I want to just show you the background behind this resonance. What is the background behind this resonance? How to understand all those things we have discussed. Now, what are the applications? If you know this and study resonance, then it will be more meaningful compared to directly going to the resonance, take the RLC circuit and all. Take the RLC circuit and all. Yes or no? Let's move. Right. Right. Let's see the following points, guys. The first point. Resonance in electric circuits. Very good. Let's crack it. Resonance in electric circuits is due to the exchange of energy between the elements called inductor and capacitor. Why resonance will occur or where resonance will occur? Whenever you have inductor capacitor present in the network, due to the exchange of energy between the inductor and capacitor, this resonance can happen. In any inductor capacitor circuit, exchange of energy takes place. We discussed this underdamped, okay, undamped, different cases we have already discussed when we discussed the basics of transients. Okay, at resonant frequency, what happens? At resonant frequency, the response will be maximum. That is, see here, if you plot the response for different frequencies, you get more response at resonance. We prove these conditions, don't worry. Your response will be maximum at resonance due to exchange of energy between inductor and capacitor freely as a function of time. Okay, so generally in the RLC, if you remember the transient may, because resistor is absorbing some energy, its oscillation size will decrease. Now resistor at one particular frequency, resistor and source will be separated from the inductor and capacitor. These things we discuss very clearly one by one. Next, at resonance what happens? The power factor must be 1, that is unity power factor condition. So when you solve any problem, keep this point in your mind. At resonance, power factor is equal to 1. Next, resonant circuits are used in many applications like filter circuits, tuning circuits, induction heating, so many n number of applications we have for this kind of resonant circuits. It is an important topic for both EC students and also EE students. So guys, I took extra time to get all these points typed and all those things. Other than your regular 1 hour, we are working background so much of time to give you the best possible content. Guys, utilize this opportunity, share this information to more and more number of students so that every single student is able to learn. Guys, let's continue. Right, so before going to the resonance, let's do the analysis of series RLC and parallel RLC. Now we are starting the original analysis of your resonance. Are you ready guys? we are starting the analysis of the RLC circuits, mainly series and parallel. First we take, later we see any circuit may how to calculate the resonant condition. So we are starting the analysis of series and parallel RLC circuits. Let's start. So if you take a series RLC circuit with frequency equal to omega, it has resistor, inductor and capacitor. So this will give you the current I. Okay. So you can replace inductor with j omega L, capacitor with 1 by j omega C in the phasor domain if you want. So I am replacing inductor with jXL and capacitor with minus jXC, where XC is 1 by omega C. So now listen here. This is VR, VL and VC. So by firstly, what is the impedance of the circuit Z? Equal to R plus jXL minus jXC. That is R plus J times XL is what? Omega L minus 1 by omega C. Okay, so this is the impedance of the series RLC circuit. Just the basics we are discussing. Then we will see when resonance occurs. Every single case we will be discussing one by one. So let us plot very important thing called 1 minute. With respect to omega, what about XL? What is XL, sir? XL is equal to omega L. XC is equal to 1 by omega C. If omega is increased, your XL will also increase linearly. Let me plot that. If omega increases, your XL will also increase linearly. This is your XL, which is equal to omega into L. What about XC, sir? What about XC, sir? Batao, what about XC, sir? XC equal to 1 by omega C. When omega 0, it is infinity. When omega infinity, it is 1 by infinity 0. So it is inversely related. Like this. So this is how your XC varies with respect to frequency. Now, what about resistance, sir? R value is independent of omega. Whatever may be the omega, R is always constant. That is, this is your R value. Now, at a particular frequency called resonant frequency, inductor and capacitor reactance cancel and impedance will be purely resistive. That is nothing but unity power factor condition. If you see before resonance in the series RLC circuit, who is dominating? Who is dominating? Who is dominating? Tell me. Capacitor is dominating the inductor. So it is lead. Is it clear? So any doubt, Shiva, please comment the particular doubt. I can explain, no problem. At omega greater than omega naught, who is dominating? Inductor is dominating. So lagging. These are the basics. We should know it. In the AC analysis we have discussed. Is it clear, guys? So this is the series Z equal to this is the impedance. This is R is a constant with respect to omega. Omega can be anything. R will not vary. What about omega L? It is a linear with respect to frequency. It is inversely proportional with respect to frequency. This is the variation of XL, XC, R with respect to omega. At resonance, your power factor should be 1. Power factor 1 means what? Imaginary part must be equal to 0. Impedance should be purely resistive. That is, this part should become 0. That is, they both should cancel with each other. Is it clear? right? They both will cancel with each other. Now, similar analysis you can do for parallel RLC circuit also. Let me do it. You have a parallel RLC circuit. Okay. So, in this, in parallel, what is same? Voltage. In parallel, what is same? Voltage. So, here you have the current in the resistor, inductor and capacitor. Okay. Now listen here. What is the admittance here? Y 1 by R plus 1 by J XL by 1 by J XC, but minus J XC. So it is equal to 1 by R plus J times omega C minus 1 by omega L, because XC equal to 1 by omega C, then 1 by X equal to 1 by omega C is omega C, right? So now listen here. If let us see how this plot will be for parallel circuit. Let us see this plot for parallel circuit, right? So listen here. If you see here, the resistance will be same in the previous case and this case. In dono case mein resistance is always a constant. I'm sorry. So admittance plot I am doing 1 by R is always constant. 1 by R is independent of your omega. Next. What about 1 by XC? Omega into C. Omega into C is linearly Y equal to mx. 1 by X equal to omega into C. It is linearly proportional with respect to omega. Okay, with respect to omega. Omega naught is 1. Omega naught will be any value. Okay. So, right, Shiva, you can understand now. Omega into C, that is, see here, omega into C is, when omega increases, your omega C varies linearly, like this. This is your 1 by XC, which is equal to omega into C. What about this, sir? What about 1 by XL, sir? 1 by XL is 1 by omega L. Omega 0, 1 by 0 is infinity. Omega infinity, 1 by infinity is 0. That is, your 1 by XL, 1 by omega L is inversely proportional to omega. This is inversely proportional to omega. That will be like this. You will be getting a plot like this. This is for 1 by omega L, that is 1 by XL. For the parallel we are plotting for admittance, for series we are plotting for impedance. Now see here, at omega equal to omega naught, at this resonant frequency 1 by XL and 1 by XC cancels and admittance will be purely conductive and you will be getting unity power factor. Next, when omega is less than omega naught and omega is greater than omega naught. Observe carefully, guys. Now you should comment omega less than omega naught. 1 by XL is more compared to 1 by XC. 1 by XL is more compared to 1 by XC. You tell me, is it lagging or leading power factor? Inductor is dominating or capacitor is dominating? If capacitor dominates, it is lead. If inductor dominates, it is lag. Please tell me. Please comment, guys. I am waiting for your answer. Very good, very good, very good. Inductor is dominating means lag. If capacitor dominates, it is called lead. If inductor dominates, it is lag and lead. Now you observe the series and parallel resonance ka basic difference. You observe they are always what we call dual to each other. Here lead is first, here lag is first. Here lag is first, last, here lead is last. So at resonance both are unity power factor. Here we analyzed the impedance, here we analyzed the admittance. Very good, very good. So these things we discuss in the phasor diagrams also. Let's move further. Let's move further. Okay. Now let us analyze something more. Resonant frequency. Please listen here carefully. At omega equal to omega naught, just now we discussed what is that J term, imaginary term of your impedance must be 0. From the plot we can say XL must be equal to XC. It is not true every time. It is J term should be 0. For that XL must be equal to XC in this case. If XL equal to XC, omega naught into L must be equal to 1 by omega naught into C. That is omega naught square is 1 by LC. What is the resonant frequency? 1 by root LC. This is what we call resonant frequency in radians per second. For what? Series RLC circuit. Similarly, for the parallel RLC circuit at omega equal to omega naught, what is the condition required? 1 by XL must be equal to 1 by XC. That is 1 by omega naught L must be equal to omega naught C. Omega naught square must be equal to 1 by LC. What is the omega naught value, sir? 1 by root LC. I want to say one thing. In resonance, there is more theory that is very important. Once you get the theory sufficiently understandable, then only you can understand the problem. So, we discuss the theory first in the best possible way. So, don't be hurry for the problems, guys. First, let me give you the foundation in the best possible way. So, the resonant frequency of the series and parallel RLC circuit is the same. F if you want 1 by 2 pi. Okay. So, right. What happened, Subhajit? Okay. Chalo. Is it clear up to this? I will inform Subhajit, don't worry. So, listen here. Right. So, shall we proceed further? This is the series RLC and parallel RLC circuit. Shall we move further, guys? Shall we move further, guys? Yes. Okay. Chalo. Now, the next part. Okay. So, listen here. Here, very important part is coming now. Listen here. At omega equal to omega naught. At omega equal to omega naught. Okay. Your impedance Z will be equal to R. What is the meaning? Impedance becomes minimum. You see here, series RLC में at omega equal to omega naught, ये part तो cancel हो जाएगा. Z equal to how much, sir? R. Z equal to R means impedance will become minimum. Impedance will become minimum. Please be careful. Then what is the current I? It is equal to V by Z, which will give you V by R. That is, the current will reach maximum possible value for any frequency. At resonance, you get the highest possible magnitude of the current. This is clear or not? Because the impedance has become minimum to the circuit, current will reach maximum. That is what I told earlier. At resonance, your response will be maximized. Yes or no? So, it is also having one name called acceptor circuit. Series RLC circuit का another name क्या? acceptor circuit. Why it is called acceptor circuit, sir? At resonance, its impedance is minimum, so it accepts more current. Its impedance is minimum, so it accepts more current. That's why it is called acceptor circuit. Series resonant circuit is also called as acceptor circuit. Is it clear? Okay, next. Similarly, if you analyze the parallel RLC circuit at omega equal to omega naught, here Z equal to, what is Z, sir? 1 minute, 1 minute. Very good. At omega equal to omega naught, your Y will be equal to 1 by R. Please see here, Y equal to, this part will cancel, Y will be 1 by R. So Z equal to how much here? R. You should comment now. You should comment now. Please listen here. You should comment now. Why here Z equal to R means, is it maximum or minimum? Is it maximum or minimum? Bignesh, we have discussed that in the AC analysis part, because in series current is same, parallel voltage is same, accordingly we take the reference, which makes the analysis easy. Okay, those things I will discuss, Avinash, don't worry. Okay, so guys, listen here, Z will be equal to R. Here very important thing, it is maximum. Now you will get doubt. Sir, here Z equal to R, sir, you said minimum, sir. Here Z equal to R, sir, you said maximum, sir. How is it possible, sir? One case mein Z equal to R, you said minimum. But same Z equal to R here also. But why you are saying maximum, sir? How is it possible, sir? How can you justify this, sir? Listen here carefully. Listen, my dear friends. In the series RLC circuit, impedance is R plus something. R plus something कम से कम R होता है. That is, the minimum possible value of R plus something is always equal to R. But here, R parallel with something. If you have R parallel with something, maximum value possible is R. You will not get more than R for any case. That is, see here. This is the maximum possibility for the parallel circuit. This is the minimum possibility for the series circuit. That is the meaning of impedance becomes minimum or impedance becomes maximum here. Here admittance becomes minimum. Here, because the impedance is maximum, earlier impedance is minimum, it accepts more current, so acceptor. Here impedance is maximized, so it accepts or rejects. Opposition is more, so you call this as rejector circuit. Yes, correct, Uma Devi. Very good, guys. So let's move further. Let's move further, guys. Up to this clear, everybody? So let's move to the next. Let's move to the next. I have provided last 2 lectures notes in the group. Please check it, guys. Just half an hour before. At omega equal to omega naught. At omega equal to omega naught. Please listen. Your Z equal to R. Okay. What about the voltage across the resistor, inductor, and capacitor? At resistor. What about the voltage across the resistor? Current in the resistor into R. Current in the resistor into R. What is current in the resistor? At resonance, what is the current we have calculated? Na? Current will be I equal to, this is same in the resistor, inductor and capacitor also, because it is series circuit. Series mein what is the resonance current? V by R. Series mein what is the current? V by R. So it is V by R into R. What is VR, sir? V. Listen. Here what is VR, sir? V. Now listen carefully, guys. At resonance, the voltage across the resistor will be, total resistor voltage will be equal to source voltage. What is the meaning of this, sir? Can I say inductor capacitor voltage 0 at this case? No. Listen here. So see here, the same analysis if you do at inductor. The voltage across the inductor will be equal to I into JXL. That is, it is all at resonance only I am saying. I will be V by R, originally V by Z, but resonance by Z equal to R into J into omega naught into L. Now, we can write this as J into QV, or you can write this as QV angle 90 degrees. Now, what is this Q, sir? Suddenly coming new thing. What is that, sir? Please listen. I will explain that. Q is called quality factor. What is Q, sir? Here, Q is called quality factor. What is Q here, sir? Omega naught L by R. That I will prove. For time being, don't worry about it. Omega naught L by R is called quality factor. Why it is called quality factor? What is the meaning of it? Everything we will discuss. Don't worry about it right now. Similarly, at capacitor, what about the voltage across the capacitor, sir? Minus IJXC. Right? So that is minus I is V by R, J is J only, X equal to 1 by omega naught C. Here again 1 by omega naught RC is called quality factor. You can write this as minus JQV or QV angle minus 90 degrees. This is the voltage across the capacitor at resonance. 1 minute guys. Here some important point I want to discuss. If you observe here, in one of the previous questions of AC analysis, I applied 100 volts, but I got more than 100, that is 200 and 200 across the inductor and capacitor. At that time I told, is it possible to get the voltage across inductor capacitor more than applied voltage? Yes, that is possible here. You observe here, at resonance, voltage across inductor and capacitor multiplied by some number called as Q. That is, voltage across inductor are magnified by Q times. That's why it is called voltage magnification circuit. So this is another name of series RLC circuit. 1 minute guys, 1 minute guys. You will get the doubt. Sir, is it violating KCL and KVL? No violation of KVL. KVL is always satisfied. V equal to VR plus VL plus VC. What is VR, sir? V. What is VL, sir? Plus JQV. What is VC, sir? Minus JQV. Then what is V, sir? V. Here, this expression anybody can say, but there is an observation here. Please observe. What is the meaning of plus JQV minus JQV here? At resonance, source is taking care of the resistor. Source is taking care of resistor. What happens to inductor and capacitor? They are exchanging energy with each other. This is what happens at resonance. This is what happens at resonance. At resonance, what happens? The source is taking care of your resistor, and inductor and capacitor will be exchanging energy with each other. That is, you see this figure, ideally what happens is they both will form a loop. They will work like a short circuit. They will be exchanging energy with each other, and the source is seeing only resistance. Source is seeing only resistance at resonance. This is what happens internally. At resonance, the voltage across the inductor and a capacitor will be multiplied by Q times, but it is not violating your KVL. This is how exchange of energy takes place. We discuss further with the help of waveforms and all. We will explain in the best possible way. Don't worry. Now, you can also draw the phasor diagram which we discussed already earlier. What is the phasor diagram of the series RLC circuit? Just a minute, guys. Now it will be okay. Is it okay now? Now it is fine. Please comment, guys. Is it fine now? Is it audible? Yeah, okay, right. Let me explain this again. This part we discussed in the phasor diagrams. If you have not attended that class, leave it. Otherwise, see here. In series RLC circuit, current is the reference. At resonance, what happens, sir? The voltage across voltage across resistor and your source voltage will be same, right? Inductor will be at a 90 degrees, capacitor will be 90 degrees because they are exactly equal, they cancel with each other, and your power factor will be equal to 1. What is called unity power factor condition. This is the series RLC circuit analysis, and it is how you can see the phasor diagram at resonance. So let's go back. Let me do the same analysis or similar analysis for parallel also. So at omega equal to omega naught, here your y equal to 1 by r, z equal to r. Now at the resistor, here parallel voltage is same. We should analyze for current. Current in the resistor is voltage across the resistor by r. What is the voltage at resonance for parallel circuit? For parallel circuit, what is the resonance at resonance? What is the voltage? Listen here. V equal to IZ, but Z equal to R. Voltage will reach maximum at resonance. So you can see the response will reach maximum at resonance, but for series case, current will be maximum. For parallel case, voltage will be maximum. For parallel, what is the excitation? Current. This voltage will reach its maximum at resonance. For series, this current will reach maximum at resonance. This is the point I told here. At resonant frequency, the response will be maximum compared to any other frequencies. Right. So at resonance, your V equal to Iz, but Z equal to R. So I into R by R. What is the meaning of it? I. So at resonance, the current in the resistor will be equal to total current applied. Current in the resistance will be equal to total current applied. Next, if you see inductor, current in the inductor will be equal to V by J XL, that is I into R by J into omega naught L. 1 by J is minus J. R by omega naught L will be given as Q here. The Q here is omega naught L by R. Q here is R by omega naught L. That I will prove. Don't worry right now. That will give you QI angle minus 90 degrees. That is your current in the inductor. Right. So next we are discussing the response at capacitance. That is the current in the capacitor is V by minus JXC. That is J times, I'm sorry if it is not visible, just a minute guys. I, it is IR into omega naught C into J. That is J times QI, or you can also say it is equal to QI angle plus 90 degrees. Here Q is omega naught RC. Q is omega naught RC. So this is your current IC. Right? Listen. So this is the response current in the resistor, inductor, capacitor. Guys, you should have some patience to learn. That is, if you directly want the problems, you will not be able to learn the subject properly. So if I give you sufficient theory, then only you people will be able to learn the subject properly. So have some patience to learn the theory first. Without theory, never try any problem. Without having proper theory, if you solve the problems also, you may get 1 or 2 question solutions. At the end of day, you will not be able to succeed, guys. Please keep this in your mind. So always have some patience to learn the theory in the best possible way. Then only we can do the problems, guys. So let's continue here. This is your IR, IL and IC, right? Here, please listen here. Current is magnified by Q times. So parallel RLC circuit is called current magnification circuit. Current magnification circuit. Okay. Is there any lag in the video? Is there any lag in the video, guys? Okay. So, right. I mean, is it clear? There is no network issue, right? Okay, fine. Thank you. Thank you. So, right, listen here. Let me do this analysis here also, then we can finish this analysis part. KCL. What is KCL here, sir? Total current I equal to IR plus IL plus IC. So, what is IR, sir? Current in the resistor is I. Current in the inductor minus JQI. Current in the capacitor plus JQI. So which will give you I equal to I. KCL is not violated, but here you should understand again important point. The total current in the resistor will be equal to this whole current is going through resistor. Inductor and capacitor will be exchanging energy with each other. This part will act like a electrically like a open circuit, and they will be exchanging with each other, and the resistor will be taken care by your current source. This is what happens at the resonance in the parallel RLC circuit. This part like a open circuit, and they will be exchanging, and resistor will be taken care by the current source. Okay, so that is current magnification circuit, right? So you can plot the phasor diagram, which is not not much difficult, but here you should plot it for voltage as the reference because a parallel circuit. So see here, current I is equal to IR. At resonance, IR equal to I. What about inductor and capacitor, sir? Capacitor current and inductor current magnitudes will be exactly equal, right? They will cancel with each other. Plus 90 degrees, and for inductor current it is minus 90 degrees. Okay, so shall we move further? Shall we move further, guys? Right. Very good. So let me give you one more thing. For the series and parallel RLC circuit, let me give you the frequency response analysis. How much is possible, that much I will cover today. Remaining we will continue tomorrow. Frequency response analysis. Listen here. If you take Z, Z is equal to R plus JXL minus JXC. Okay. You can write this as R plus J into omega L minus 1 by omega C. That is, what is the magnitude of the Z? It is root of, it is root of R square plus omega L minus 1 by omega C whole square. Now, what is the meaning of the frequency response is the current in the resonant circuit or series RLC circuit is its voltage magnitude by impedance magnitude. So, here the voltage magnitude by impedance is how much? Root of R square plus omega L minus 1 by omega C whole square. Everybody here carefully listen. Everybody here carefully listen. Here the current equation, whatever the current equation is there, it is a function of frequency. When omega is a variable quantity, with respect to omega, then your current will also vary. With respect to omega, with current also vary. For example, see here. Let me substitute here. If omega equal to 0. If omega equal to 0. 1 minute, guys. Right. So listen here. If omega equal to 0. So listen here. If omega equal to 0, what happens? Omega equal to 0. See here, if you substitute here 0, 1 by 0 is infinity. So your Z will be equal to infinite. Agar Z infinity hai to 1 by infinity, current will be equal to how much? 0. At omega equal to omega naught, your impedance will be equal to R. Z will be equal to R. These two will cancel. The current I will be equal to V by R. Next, omega equal to infinity, Z equal to 0. Sorry, Z equal to again infinity, and current I will be equal to 0. So if you plot this part with respect to frequency, if you plot this waveform, the magnitude of the current response will be like this. That is, it will be maximized at resonance. At omega equal to omega naught, the current will reach its peak possible value, that is highest possible value. And there are two intermediate frequencies which are defined, which we call lower and higher cutoff frequencies, where your current high here will be I maximum and here it will be I maximum by root 2. Some people will, most of the people will be having the misconception this as I maximum and this as IRMS. IM by root 2 is there. Now what is this IM by root 2? So people will say it as a RMS value. Please take it as a wrong answer. Why this root 2 comes? It is not, don't relate this IM with your peak value of the current. Here IM is the peak possible value for the current magnitude. So that confusion will be there for the so many students, or misconception like here IM is the maximum value, IM by root 2 is the RMS value. That is wrong answer. Okay, please understand that here IM by root 2 is only taken. Why root 2 is taken? I will explain. See here. Here power will be the current. Assume the magnitude is a RMS value. That is, here IM is not a maximum value. It is the peak value of the magnitude, highest possible magnitude value. I will explain little further also in this. Don't worry. This is IM by root 2 whole square into R. That will give you IM square into R by 2. That is, here you take P1, you take P2. P2 equal to P1 by 2. This is called half power point. What is these 2 points are called? Half power points, where the power will fall to half of your maximum possible value. If you go below this frequency or above this frequency, the response will further fall. That is why these are the points called as half power frequencies, or what we call lower higher cutoff frequencies. We generally take this part as your response pass band and this part as your stop band. That is, here from this point to this point, I guarantee minimum 50% of my response. That is, in this frequency range, my response will be minimum 50% of the maximum possibility. Below this, the response will fall. Okay, so guys, tomorrow we will discuss what is the value of WL, WF, what is the difference between why this, why it is not RMS value, what is this is not maximum value. Every single clarity I will give you. Now the time will not be sufficient to discuss that, but I am giving you one point in your mind. This is not maximum value and RMS value. It is the magnitude peak and magnitude by root 2. Why not root 3 or root 4 or root 7, something else? Every single point minutely we will discuss. And how, what is the significance of width of this curve? If width increases, what happens? Every single point will come tomorrow class. What is the quality factor? Every single minute detail will come in tomorrow class. Because today it is not sufficient to teach more. So I will stop here, guys. Yes, Avinash, I will come to those points tomorrow. Okay, size, significance, every single clarity I will promise you and I will give you. Today it is not possible to discuss that because I don't have much time now. Right? Is it clear, guys? Shall we move further? Are you ready? So tomorrow, please stay tuned. I will clear your doubts of the difference between these two most happened misconception kya. In the best possible with example, I will clear you why root 2 is taken and why it is called 3 dB point. Everything will come into picture tomorrow. And how to derive quality factor, how exchange of energy takes place. Tomorrow is also completely I will discuss theory, but it is very important for understanding the problem, solving the problems. Okay guys, let's revise the things. So this is about your series RLC circuit, parallel RLC circuit with respect to omega, its impedance, reactance, resistance and whatever inductor reactance, capacitor reactance and resistance variations, and resonant frequency. At resonance, what happens in the series and parallel, and also voltage magnification and current magnification. Then we are starting the frequency response. This part we will finish tomorrow. What is lower cutoff, higher cutoff, every single formula, everything I will provide you. Tomorrow we will continue. Don't miss the class tomorrow, guys. Okay. So tomorrow we discuss more and more number of things. So please don't miss it. Tomorrow also same times. Okay. Vani Ubaid, PYQs, we are not taking special class. I will tell you the reason. See, I am not taking that. There is a channel. Please go through this channel. Unacademy GATE questions. In this, I solved already previous questions of 2 years. 3 more years I will upload in 2-3 days. 2016 to 2020. All network questions I will solve and upload it here. Not only me, all our faculty are doing this. Okay, this channel you subscribe and follow, you can find the previous questions. So please continue guys. Every day we are having live from where to where, 5:30 to 6:30 is the time every day. Please don't miss the live guys. I will give you the best content if you come in live more and more number of students. So some people are asking for iconic subscription. If you go for iconic subscription, you get personalized coach, study planner will be provided, expertized guidance will be provided, ESC mains and question. It doesn't mean we neglect the plus students. For plus students also we provide everything, structured schedule, unlimited practice, test series, everything is available. Iconic will they will get extra care for this, right? For both the cases you can apply my coupon code Sankar 10, right? For plus it is 25k, iconic it is 45k for 1 year, 2 years it is 60 and 30. These are only up to October 20. After that you cannot get it. October 19th you can say. For 20th onwards your fee will be hiked. So don't waste your time or don't delay it. If you have a plan for subscription, you just take it as early as possible. Love you, Govind. Thank you. Right? Yes, Chinna. Good evening, Abhishek. Okay guys, so tomorrow we will meet again at 5:30. We will discuss more and more number of theories. So don't miss the classes guys. So attend this class and next class we will be solving next class also theory. Then we will start solving the problems. You will not be able to understand the problems without theory. If you skip one class, it will become habit for you. Don't make a habit of skipping the classes guys. So right, so we will meet again. Subscribe to all our channels and share with more and more number of students. We will meet regularly and we will give you the best possible content guys. Thank you very much. Thank you very much. We will meet again tomorrow 5:30. Share this video to more and more number of friends guys, then we can meet tomorrow again. Please make it as a your responsibility to share with more number of your friends or your college groups guys. Thank you.